Bismillahirrahmanirrahim. Assalamu alaikum. Today we are covering another important topic from the field of numerical methods under the title of interpolation. What is interpolation? We shall see it during this lecture, and in this regard we shall be covering two different numerical techniques of interpolation. One of them is the Newton's forward difference interpolation formula, and second is the Newton's backward interpolation formula. So these are the two formulas we are going to cover during this lecture. I'll be giving only the proof of the first method, named as the Newton's forward difference interpolation formula, and second we shall be writing down directly with a minor change into the formula of the Newton's forward difference interpolation formula. So here we take start the interpolation. Interpolation is basically a process in which we can approximate a value at a certain point within the given range of these data points, but not actually present within the data. The process, whenever we are looking at a value within the range, is known as the interpolation, and whenever there is a value which is out of the range of the given set of points, so the process is generally named as the extrapolation. So these are the two familiar terms, you already know about it. So here we are going to take start the first method, named as the Newton's forward difference interpolation formula. So let me write down the title of the method which we are going to cover is named as Newton's forward difference interpolation formula. Okay, so this is the title of the method which we are going to cover. So in order to take start of the method, we are supposed we have a set of points, say xi and yi, where I goes from 0 and so on up to n. So this is the given set of points, and you can see these are n plus 1 points, and now we are going to approximate these points with an nth degree polynomial, say yn of x. Yn of x is the nth degree polynomial, and we are going to approximate these set of points assuming that the output of this nth degree polynomial is equals to the value of y from these sets. So in other words, y and y of nx are going to be same, and we assume that these are almost the same depending upon this nth degree polynomial. What is this polynomial? So let me define this polynomial here. So let me write down the nth degree polynomial which we are going to work on. Yn of x is the polynomial in which a0, a1 x minus x0 plus a2 x minus x0 x minus x1, a3 x minus x0 into x minus x1 x minus x2, and you can write down many more terms, and then we can write down an x minus x0 x minus x1 x minus x2 and so on, and x minus xn minus 1. So this is the polynomial which we are going to use to approximate this set of points. And you can see here in this polynomial all the a's, a0, a1 and so on up to an, these are all constants. And the task is, first of all, we have to determine their values. How we can find out these values? In order to find them out, we'll be making use of these points. So we substitute the points one by one from the given set into this polynomial. So here we take start putting x0 and y0. or in other words at the point x0 and y0. You can see here whenever I put these values into this polynomial, on the left side this can give you, suppose, y0, the corresponding to this value to this left hand side. On the right side you can see all the terms except the first term will become 0. So the result takes the form y0 equals to a0. So you can see here we got the first unknown, which is a0, in the form of y0. So here we got the first unknown. Now we shall be working on the same line for the second unknown, which is a1. In order to obtain this second unknown, I'll be putting the second point. So just to create the space, let me erase these things from here. Okay, now we to find out the second unknown, will be taking or putting x1 and y1. So here we get y1 on the left side. On the right side you can see, except the first two terms, all the remaining will become 0 due to the presence of x2, x1 here and all the terms after this. So the result takes the form a0 plus a1 into x1 minus x0. So here you can see, on substituting this point into the polynomial, we get x1 minus x0. It's okay, that's correct. Now we know the value of a0, which we have just calculated, so I can put this value here. It takes the form y0 plus a1 into x1 minus x0. So now we can, I request you to all to keep this polynomial in your mind, because I have to put one more point and there is a bit less space. So in order to create more space, I'm going to erase all this. Okay, after doing this, we simplify it to separate a1 from these terms. In order to separate a1 from here, we can write it in the form of a1 is equals to, on shifting this on the left side we get y1 minus y0, over on dividing this we get x1 minus x0. So here you can see we got the second unknown a1, which is y1 minus y0 over x1 minus x0. Now we know that the numerator is equals to del y0 and the denominator is the increment, as I have told you in the previous lecture. In moving from x0 to x1, we assign an increment of h units. So this can be obtained just by taking the difference of these two. So here we replace it by h, and this is a more compact form instead of writing this one. So we succeed in finding the second unknown in the form of a1. Now you have to keep these values in your mind, and at the end whenever I'll be using them back, so you must have these in your minds. Okay, now to find out the third unknown, which is of course a2. So in order to obtain its value, we'll be using the third point, which is of course after this one x2 and y2. And I hope you have the polynomial in your pocket. You can use this point and putting into your polynomial, and on substituting it you will see except the first three terms on the right side, all the remaining will become 0. So the result takes the form, on the left side this gives you y2 a0 plus a1 into x2 minus x0 plus a2 into x2 minus x0 and x2 minus x1. So these are the three terms you will be getting whenever you substitute these this point into the polynomial, which we have written just a few minutes ago. After doing this, now we have to separate this a2 from here. Now in order to separate it from here, I am putting the values of these two constants which we have already obtained in the one of the values still on the board. You can see I can replace it by this one. So here we are going to put in the values. So a0 is equals to y0, and a1 is, instead of writing this value, I'm using this part. So this gives you y1